All right. One of the key ideas about this walking around thing is that you get, hopefully at some point, a sense of when it's time to change direction. You know, when it's time to ask another question, to give a hint, whatever, or time to move on, or time to sort of get some closure on this. So there are several tables that are convinced they have the right answer. None of the two tables agree as to what the right answer is, but they're convinced that they have an argument. I'm going to start over here with Rob, who says that he can prove that there are 46. Now, you have two choices. You can go up there where there's a mic and everybody can hear you, or you can talk loud. And I will give you...
I'll start with the 1 by 1, the 2 by 2.
Okay, hold on. Okay, so you're going to start... Let me just get rid of all my drawing here. Okay, so we're okay that if we do it as a 1 by 1, 2 by 2, and all that, then we get 30. So we're going to start with 30. So the question is, how many are there above and beyond 30? Okay?
I used the square root of 2.
Can you hear him?
I used this square root of 2. Then I use square root of 5. And it's basically because there's a 1 by 2 right triangle there inside square root of 5. And there are 4 of those.
1 by 2 and 2 by 1. You do a 1 by 2 with the slope of 1/2, or then you do go 2 by 1 with the slope of.
Okay, you're going to get to 4. We're okay with that.
But then if you go the other direction with the slope, you get the 4 and 1.
Okay. Also, let me give you a hint. If you touch another color up there on the left, then it'll change the color of the pen, and that'll be easier to see. Okay? You see what I'm talking about? There's a palette on the left. If you touch the pen to one of the other colors, then it won't be, it'll change the color. Okay, we've got those. Do you see the other ones they're talking about?
Are we at 8? Then I use square root of 10. I felt there was only 2 there. Not square number. And then I had twice the square root of 2.
Yeah, where's that one?
Are we happy with that? There more? You're convinced that you've got them all? All right. Now, I don't think we're quite done yet. And the reason I don't think we're quite done yet is that I want to ask you a question about Rob's work. Do you like the way he organized it? Is it true that part of the difficulty of communicating is how are you going to organize this so that other people understand which ones you're talking about? Because the drawing gets real confused real quick. And the other part of it is, are we sure we've got them all? Are you sure? How much money would you bet? How much are you willing to bet that that's the right answer?
Me?
Yeah, it's your solution.
Oh.
How confident are you of your answer? Now, I've never taken money from a kid in class for that sort of thing, but I want to know. And it's a way of sort of putting it on their own terms is, are you sure there isn't another one? And part of the learning experience that's going on here is, I will point out to you that there are many bright people in the room who were sure that there were 30 because they didn't think of the slant ones. So we thought of the slant ones. Are you sure you've got them all? Is there something about this arrangement that gives us a convincing argument that there are no more? The 1 by 1, 2 by 2, 3 by 3, 4 by 4, that was pretty convincing. Is this convincing? Could there be a root 3 by root 3 one someplace? Root 3 by root 3, root 3 by 1. That would be a square. But what about, okay, root 3. Do we have that one? Okay, that's root 10. Right. Is there another way that we could organize this that would be different? Maybe not better, but another way we could think about this so that we could, well, just another way to look at it. Okay, Nancy, you want to? No, somebody want to? Okay, Nancy said slopes of lines. I could do that, but I'm not exactly sure what you mean.
Oh, if you...
So just write. As a friend, do it.
As we're taking a look at the diagonal one, like here, this one, okay, we know that that's a slope of 1, and if this is to be a square, its other side has to have a slope of -1. So if I find all the different slants, slopes of the lines as I'm going across that I can possibly make, and then I look at their opposites, I could go this direction as well, then I know that I can get all the different combinations. Does that make sense?
And so the slopes that you used are 1.
Actually, they are 1/3 and -3, positive -1.
Could you write that down?
Okay. Slopes. 1/3 and -3, and that was for the root 10 by root 10s. Slopes of positive and -1, and that was for the root 8 by root 8 and the root 2 by root 2. And a slope of 1/2 and -2 for the root 5 by root 5. So if I looked at all of those, I looked to see if there were any other slopes possible and still have its opposite reciprocal land on the grid. So I went through all of those and then went back.
And you got
I still got
And you still got 50. Okay. Does anybody have a slightly different way of looking? Yeah.